This is Dr. Sirisha, working as Associate Professor in Institute of Aeronautical Engineering College. Today we are going to discuss about a sorting technique known as insertion sorting. Let's look at what a sorting technique is. Sorting is nothing but arranging the elements in either ascending or descending order. Right? There are many types of sorting techniques are there, like bubble sort, insertion sort, selection sort, quick sort, merge sort, and heap sort. Today we are going to discuss about insertion sort. Insertion sort is nothing but arranging an element, picking an element and placing it in the right position by the end of each and every iteration. Right? So coming to the complexities of insertion sort, the best, average and worst case is bigger of n square. That doesn't make any change even if the list which we have in our hands is a sorted one. The comparisons or the number of comparisons, if we call, will be the same. That will be order of n square. The memory which it is going to use is very small, which is order of 1. Only the memory required will be for the given list as well as the temporary variables which we are going to use. That's it. And it is an in-place sorting technique, right? So let's have a look at the algorithm of insertion sort. So the first step involves the comparison of the elements in the given list with its adjacent elements. Say our point of concentration starts with the second element. Right? So our point of concentration, when it starts with the second element, we are going to compare with the elements which are having lower index value than that. Right? So by the end of each iteration, as I said, every element get its right position. I'm going to explain you this sorting technique using an example. Let's have a look at this example. I've taken 5 elements. It is an unsorted list, you can see. 21, 54, 36, 18 and 29. So I'm going to take 2 variables I and j, where initially I will be holding the index value 1. As I said, I will start comparing with the second element in my hands. Right? So j will be holding an index value 1 less than I. So here starts the process. Right? So key will be a variable which is going to always hold the content pointed by the variable I, right? So our task is to place the key at its right position by the end of iteration. So as we do not know how many times we are going to run this, I'm going to use while loop rather than for loop. And there will be 2 conditions which I need to take care of. The first one is the key value must be less than the value pointed by j, right? The key value must be less than the value pointed by j, and the j value must be greater than or at least must be equal to 0. These 2 conditions must be satisfied. If these 2 conditions are satisfied, then I can place the value of j. That means the jth value, whatever the value in the list which j is pointing to, in j plus 1th position and decrement the j value. Right? If any one of the condition fails, then the loop fails. Right? By incrementing the I value. If the condition fails, I'm going to increment the I value. So here in this scenario, have a look at this scenario. In this scenario, the key value is 54 and the value pointed by j is 21. So compare between these 2, 54 less than 21. Is it true? No, the condition failed. As the condition failed, the loop gets broken and the value of I will be incremented. So as the I value incremented, again the process of initialization starts, where j is going to hold a value 1 less than I and key value will be the value pointed by I. Here I is pointing 36. So the key value is 36. Okay. So again the while loop starts. So compare between key and the element pointed by j. So here the key is 36 and the element pointed by J is 54. Is 36 less than 54? Condition satisfied. So if the condition is satisfied, in J plus 1 position, place the value given by A of J, which is 54. So now the index value 2 is holding 54. Guys, don't get panic. 36, we didn't lose that value. The variable key is still holding 36. We didn't lose the data. Okay, so we are in a process to get a right position to that, to find a right position to that, right? So loop didn't break, right? As in the previous case, in the previous step, we can say both the conditions were satisfied, right? So the while loop still prevails, and now here the key value is still 36, but J is pointing to 21. So is 36 less than 21? Condition fails. Condition fails means the while loop breaks. Once the while loop breaks, so we are going to come out of the loop and J value gets incremented. Before that, the key value will be placed in the J plus 1 position. So at index 1, 36 is going to sit. Right? Now, as I got incremented, now I is pointing to index value 3. Again, the process starts. J will be getting an index value 1 less than I, which is 2. And key will be holding a value pointed by I, which is 18. So again, the process starts. Check the conditions. So here the key value is 18 and J is having a value 54. J is pointing to a value 54. So is 18 less than 54? Condition satisfied. If the condition is satisfied, so place the value pointed by J in J plus 1 position and decrement J. So the result of that will be at index 3, you are going to have 54, a copy of that. And J is pointing to an index value 1 and a value 36. Right? So as the loop didn't break, again the process starts. Comparison between key value, which is 18, and the element pointed by J, which is 36. Is 18 less than 36? Condition satisfied. Now place the value pointed by J, which is 36, in J plus 1 position and decrement J, which results in, so index 2, 36 will be placed and J gets decremented and it is holding an index value 0, right? So as the while loop didn't break yet, we are still in the while loop, hooked in the while loop. Let's go for the comparison. Now again the key value is still 18 but J is pointing to a value 21. Compare between these two. As 18 is less than 21, the condition satisfied. Obviously, J is not greater than but equal to 0. Even that condition is true. So condition satisfied. Now place the value pointed by J, that is 21, at index value 1. Right? So 36, which is right now at index value 1, will be overwritten by 21 and decrement J. So have a look at this one. Now index value 1 is holding 21 and J got decremented. If J gets decremented, what will happen? The while loop is going to break. Why? J will be now holding -1, which violates the condition J greater than or equal to 0. Right? So now the while loop breaks. Once the while loop breaks, place the key value in J plus 1 position. So at J plus 1 position, which is 0. When we decremented J, it went to -1. So I am incrementing it to place the value of key. So at the index value 0, 18 will be placed and I will be incremented. So as I got incremented, now I is pointing to index value 4. The process starts. J will be holding an index value 1 less than I and key will be assigned a value which is pointed by the variable I, which is 29 right now. So the while loop starts a comparison between a key value and the value pointed by j. So that means it is a comparison between 29 and 54. Is 29 less than 54? The condition satisfied. If the condition is satisfied at j plus 1 position, place the key value, right? 54 will be placed and j will be decremented. So have a look at this one at index 4. 54 is being placed. Don't worry, key is holding 29. We didn't lose the data yet. Okay, so as j got decremented and the loop still prevails. So have a look at the values. Key is less than 29 and the value pointed by j is 36. Is 29 less than 36? Condition satisfied. As the condition got satisfied at j plus 1, place the value pointed by j, which is 36. That means index value 3 will be the value, right? The value at the index value 3 will be overwritten by 36 and j will be decremented. The result of that will be like this. Now index value 3 is also holding 36. As j got decremented, it is pointing to index value 1 and a value 21. The while loop. Again start comparing. Key is still holding 29, whereas j is pointing to a value 21. Now, is 29 less than 21? Condition failed. If the condition fails, what we have to do? Place the j plus 1 position, place the value of key and increment j. So, that's what I have done over here, right? So, as the condition got failed, so now if you increment the I value, I is going to go out of the limit because the upper boundary is 4, and if you increment I, it will be pointing to 5, which is out of limits. So once I crosses the limits, that is the upper bound, it will be the end of the logic. So the final list is in your hands right now. The final sorted list will be 18, 21, 29, 36 and 54. Guys, I hope you understood insertion sort, right? So it is a process where you are going to start the technique with the second element in your hands and start comparing with the elements which are having a lower index value than the second one, right? If the conditions fail, increment the ith pointer and continue the same process, and the exit point of this technique will be when I crosses the upper boundary. When I crosses the upper boundary, by that time you can see that a sorted list is in your hands. I hope you understood insertion sort. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.